starts to. You will have this kind of graphical user interface with several sections that are quite important. Starting from the top, you will have some process controls. These are essentially shortcuts to things that you can do through the menus or with right clicks, but they are there for people who are a little bit more lazy, like me. And they will allow you to start, stop the debugging session, step through functions, set up breakpoints, etc. There is a section that is very important, which is the process groups window. This section is very important because you will be able to set different groups of processes within your own execution, and you will be able to focus on each of these groups separately if you need to for the debug session. And I will go into this with a little bit more detail in a couple of minutes. Starting from the left, you will have a project navigation window where essentially all the source code that you're using, and that includes external libraries that you might be linking with your code, etc., will appear. You will have a code window that by default when you're opening your main program, but where you can open anything else. A variable window that includes local variables, the current stack, and a few other things like the local variables that you have in the current selected line. And in this case, you can see nprox equals some ridiculous number because we haven't actually started running the code, so nprox is not really being defined or initialized in any way right now. On the bottom part of the screen, you have a stack view and output window, and this is very important once you start your debugging session because this is where you would get information about any output that your code normally put in the standard output or standard error, and also what's the current stack information when you stop the code. It will tell you where each of the different tasks or threads are. And then you have an evaluation window where you can actually add different variables or expressions to evaluate while you're doing a pause part of the debug session. So I'm going to now go into a bit more detail in each of these sections. First of all, let me talk about process control because right now I've only explained how to start the session. We haven't absolutely done anything yet. Our code hasn't even started running. So the first thing is that in the stack window, that window that I showed you before on the top right, you can see the local variables for any currently selected line, and you can also see the local variables for this function. In the bottom left, on the parallel stack view, you will see where each thread is positioned or where each task is positioned, depending on the type of code that you're running, at the moment when you stop the execution of the code. So these two are critical to identify problems. Once you start running a code, put a few breakpoints. When you stop at a breakpoint, you're going to want to examine this. Sorry, I was running a debug session in the background and just popped at me. So once you stop at a breakpoint and want to try to analyze your data, these are two windows that you're going to be using all the time. I mentioned before that an important thing with DDT is that you can create process groups. So by default, DDT will create three sets of processes. One that contains all processes in the job, one that contains a root process, number 0, and another one that contains all processes other than 0, which is by default called workers. These are just default groups, but you can create any groups that you want. Say that you wanted to create a group only with even valued process IDs. You could just do a control click on, in this case, 02, 4, 8 to 16, and then right click on that selection and say create group. That would create a new group which has some assigned name by DDT, probably a name group 1 or user defined 1. And once you have this group, you can do the same operations with this new group as you could do with the others. So you can focus on this group now instead of on the group that contains all tasks. You can edit its properties, so you can change its name to something that you will understand when you're working on a long debug session, etc. So this is pretty handy when you have groups of tasks that do fairly different things and you want to analyze what's happening in one of those parts of the code. If everybody is doing the same, this facility might not be as useful for you. Changing focus from a group of processes to a particular process or to a particular thread is very easy. You can just click on Control, Focus, and then select what you want to do. Or you can just directly select from the toolbar Group Process Thread. And then your focus will change. And as you see, as soon as I say Focus on Current Process, the way that the groups are displayed on my group bar changes to what you can see on the bottom left, where now it appears as all the groups are there, but I'm only focusing on process 0, which is only executing one thread at the moment. Now, a very important part of a debug session is how to insert breakpoints and watch points that I will talk about in a moment. In DDT, you can do this in a multitude of ways. You could simply hit the breakpoint button on the toolbar, or you could go to the menu, add a breakpoint, just double-click anywhere, or right-click and add a breakpoint to a particular source code line. Once you add a breakpoint, in your windows on the bottom left, you have a tab for breakpoints, watches. This is the same window where you normally look at your standard output, your standard input, and the stack status. And here you would have a list of all the breakpoints that are currently in the code, and you can activate them, deactivate them, or you can create conditional breakpoints from them. Conditional breakpoints are particularly useful when you suspect that you have an issue inside a very long loop. In this case, you don't want to create a simple breakpoint inside that loop because you will have to be hitting continue for probably all the iterations of the loop except the last one where the problem actually is. What you want to do is you want to create a breakpoint that only actually executes, only actually stops your runtime execution when a certain condition is reached. Doing this in DDT is extremely simple. You can select any breakpoint that appears on the breakpoint tab and do a right click and say edit breakpoint properties. And there you will see that there is at the bottom a checkbox for adding a condition to this breakpoint. That condition can be added in Fortran, C, any language that you have used. Usually DDT will be pretty adept at guessing what language you use, but you can also explicitly tell it. And the condition must be just the condition itself. In other words, you don't need to write the full if statement. So you don't write if dx is smaller than 0, do something. You just write the condition itself. Common source of frustration is when people actually write the whole if statement and then DDT refuses to add that conditional breakpoint. So that's something to remember. Once you add the breakpoint and you add that new condition, that change will be reflected on the breakpoint tab on the bottom left of the screen, as you can see in this picture. Now, on other occasions, we don't want to add breakpoints. We actually want to watch particular variables changing in time. What we want to do is we want the debugger to tell us, hey, I'm going to stop right now because this variable changed its value from value A to value B. In that case, what we want to do is not to insert a breakpoint, but a watch. The easiest way to add a watch in DDT is to just right-click in the watch window and add a new watch where you specify the variable name that you want to watch for. Another thing you could do is in the local variable window, you could select any variable that appears there and right-click and add it to the watch list, as you see in the second example. So this is pretty easy to set up too. I personally use a lot more breakpoints than watches, but I suspect if you're using threaded code, this must be pretty useful for you. Once the watch point gets activated, DDT will stop, but it will give you a warning. It will tell you, I'm stopping at watch point, whatever, and it will tell you where, which gives you the chance to either continue and ignore this, or pause and effectively insert a dynamic breakpoint, and then continue having a look at your data and trying to analyze what is going on at this stage. So now I'm going to move to viewing and editing data in DDT, but I've already gone through quite a bit of the basics for how to initialize and how to start a debugging session. So I was wondering if we have any questions from the audience? No? Okay, then I'll continue. Hopefully I can let you all go a little bit earlier than expected then. Viewing and editing variables is a pretty simple affair, but the problem is that we don't only deal with scalars. We have vectors, we have matrices. So how to look at this data in a way that we can understand what we're seeing, particularly in a parallel environment, can be quite complicated. And DDT offers you so many options to view data, sometimes you don't even know what's the best way to go about this. Local variables will appear in the variable window that we have on the top right of the GUI, and you can drag and drop them into the evaluation window just to see their values or to play with them. One thing that sometimes is useful, particularly if you want to have a look at something that is inside a pointer, or dynamically allocated array, is to right-click on the variable and say, I want to view this as a vector, in which case that variable will be added to the expression window, but it will be unfolded so that you can see its content too. You can also edit variables. You can edit both the type and the content inside the evaluation window. And if you do this after you restart the execution, once you are happy with what you've seen from the debugger, this change in the variable value will happen in the runtime execution as well. So if say that you have a value that you know shouldn't go below 0, and you put a conditional breakpoint to watch for that, you could change that variable to be greater than 0 again, just to see where the next problem with the code could be, and continue execution. That way you wouldn't have to restart the whole debugging session again. So this editing of variables is quite handy. One thing that is particularly useful when we are working in a parallel environment is to compare the values of a variable across different processes. If I'm running 16 processes, or if I'm running 200, I might want to look at a particular variable and see what values it takes in different processes. In some cases because I don't expect this value to change, and in some cases because I do. Instead of having to look at this one by one, process by process, DDT offers you the possibility of just doing a cross-process comparison. What you do is you go to the View menu and then select Cross-Process Comparison. You can also do a cross-thread comparison, which would be the equivalent for a threaded code. And that will show you the value of a variable across all the tasks that you're focusing on at the moment. So for example, in this